Hi Chem Peeps, this is video 4 on thermodynamics, and today we're going to talk about enthalpy, which is abbreviated delta H. And so what actually is enthalpy? It's the measure of the change in heat of a reaction. And so how we calculate them is what we're going to be talking about today. And so when you calculate the enthalpy, you're going to take the difference in energy between the reactants and products. So specifically, for a reaction, the enthalpy is going to be the sum of the products minus the sum of the reactants. And oftentimes your book will have a chart, maybe in the index or in the chapter on thermodynamics, where you can look up different substances in different states of matter to find their actual enthalpy values. In this video, I actually picked problems where the values are given to you, so we didn't have to look them up. So let's look at problem set number 1 over here. It says the heat of formation of H2O2 is a negative 187.6 kilojoules per mole, and the heat of formation of water is negative 285.5 kilojoules per mole. Determine the delta H for decomposition of hydrogen peroxide. And so basically we're going to find the enthalpy of this reaction. So I always tell my students to find the delta H, I first tell them to write out the products first. So there are 2 waters in liquid state plus oxygen. So this side is our products, and so I have that on in the equation first. And then we're going to subtract it from the reactants, which are 2 hydrogen peroxides in liquid state. And then I got gas here. Okay, and you're saying, why do I have to write the phases? Because water and solid, liquid, and gas is going to have a different heat of formation value. So when you look them up on the chart, you want to make sure you're looking up the right state of matter. Also, what's very important are the coefficients, which tell you the number of moles. All the values on your chart, or what's given to me in this problem, are for 1 mole. So quantity does matter here. So then I'm going to substitute in the values that are given to me for each of these substances. So I'm going to have 2 times the water value, which is a negative 285.8 kilojoules. And you'll notice that they did not give you oxygen because we don't form elements. Elements are already existing. And so we're only going to have values for enthalpy for formation of compounds. So in this case, it's going to be 0. So then 2 times the hydrogen peroxide value, which is negative 187.6 kilojoules. So if I simplify this, I am going to get an answer of negative 196.4 kilojoules. Now, they don't ask us to do this, but I always give this as good practice for my students. Is this reaction endo or exothermic? Well, since there's a negative value here, it's going to be exothermic. Okay, so let's look at the next problem. In the next problem, it tells us that we have the heat of formation of carbon dioxide and water are negative 393.5 kilojoules and negative 285.5 respectively. Determine the heat of formation of methane. In other words, we're solving this. And you can see in the equation that they gave us, they told us the enthalpy of this reaction. So we're actually solving for a substance in here. So let's do what we did before, and let's go ahead and set up the problem. So the enthalpy is going to be the products minus the reactants. So it's going to be the carbon dioxide plus the water, 2 of the waters, sorry, minus the methane plus 2 oxygens. Now, if you remember from the first problem, oxygen is an element and it's not going to be formed, so that's not going to have a value. So we're really solving for this methane here. So the enthalpy they give us is negative 890.3 kilojoules, and we're going to set it equal to the carbon dioxide, which is negative 393.5 kilojoules, plus 2 times the water value, which is negative 285.8 kilojoules, minus the methane, which I'm going to label as X, just to simplify there. So if I solve for X in this problem, which is the methane, I am going to get an answer of negative 74.8 kilojoules per mole. Okay, because that's the units that they're using in this problem. And so that's how we use enthalpy to calculate the formations of different substances or of the reaction. You can find more on thermodynamics on YouTube and TikTok at Chem's Chem Chats, and I will check you later.